Hey guys, Midecali here. Welcome back to my YouTube channel. Today we're going to be looking at fundamentals of electric circuits, which is the very first thing, as always, relationship between charge, power, energy, and voltage. So as you can see here, charge is always represented in Q, with SI units coulomb. Power is always represented in P, which SI units watts. Energy measured in joules. Voltage in volts. Current in ampere. So we all know that I is equals to change in charge over change in time, and we as well know that voltage is equals to change in energy over change in charge, and power is given as change in watts over change in time. So for this power, as you can see, we could still go further. Everybody knows power is equals to current times voltage, but how was that derived? We don't see it clearly in between these two equations, but how was that derived? First things first, we make T the subject of the formula here, and we make W the subject of the formula here. Doing that, we have T is equals to Q over I, because I cross multiplies these, then make divided both sides by T, or multiplies both sides with T, right? Here, making W the subject of the formula, it becomes W is equals to V times Q as voltage times charge. So substituting these values here, we have P is equals to our W, which is VQ, divided by our Q over I, which becomes VQ times I over Q, where Q cancels Q, and we have our power to be voltage times current, measured in watts. This is power. Now for energy, which is W is equals to P times T. This is the first formula, but we could still go far, right? Looking here for our currents, we could also say that charge Q is equals to I T, which is current times time. This is charge Q. So looking at energy, we have it to be W is equals to power times time. Looking at energy here, we have it to be W is equals to power times time. We could simplify our power by saying W is equals to VI times T. We could go much further as saying that high T here looks the same thing as our Q. This is our equation 2, right? We could as well say that energy is equals to VQ, which is our equation 3.